Input and output. Hello everybody, this is Ben Finkel, and in this nugget we're going to take a look at how we can get input from the user from the keyboard and print output to the screen to the terminal window with Python terminal window programming. Now to start off this nugget, we're going to take a look at the various input and output functions that we're going to use, specifically raw input and print. After that, we'll get right into our code and we'll talk about how we can parameterize the print function. And this means passing multiple values into the print function so that it can do different things, actually concatenate strings together for us, and even impact the way that those strings are concatenated. Then lastly, we'll finish up by taking a look at how we take input from the keyboard and how we can use that throughout our program, including various data types such as integers and floats, and how we can use different operators like plus, minus, divide, etc. in order to perform math operations on that input. It's a lot to cover in this topic, so let's get started. So you're ready to get some information into and out of your program. It's called input and output. And of course this is important because it's great and all to write a program with set static values and see it execute, but what we really want to do is have a program that's going to vary or change based on the input it receives and show us differing outputs so that we know that it's executing correctly. Now a little side note here, throughout this video and throughout the most of this series, we're going to be interacting with our Python programs in something called terminal mode. And terminal mode is a mode that's available on all operating systems, and it's essentially a command line interface. It's that black screen prompt interface that we've been using, although you'll see in my demos I use a white screen. But the basic idea is that you, in terminal mode, can write commands directly down to the operating system. So you may think of modern computer programs as not dealing with this at all. Modern computer programs are fancy. They have buttons and whizzes and gadgets. You can drag and drop things. They got flashy graphics, all that stuff. Well, the short story is, for every one of those programs that you are used to interacting with, there's a dozen or more programs behind the scene that you never see running, that you never work with and you never touch. So we are going to be focused on developing that sort of application, and we need to use terminal mode in order to interact with this application that's running behind the scenes. The goal for us ultimately will be to create programs that run more or less without our interaction, or with minimal interaction from us as possible, and use terminal mode to see some output and see some logs and make sure that things are operating the way we expect them to. So to begin with, to get information out of our program and onto the screen, we're going to use a command that you should already be familiar with, and that's the print command, or the print function. And remember, the print just takes whatever is here in between the parens and outputs it to the screen, or in our case it's going to put it into the terminal window that the application is running inside of. Now we're going to do some new things with the print that we didn't do in the past. We're going to add something called parameters into the print statement, and all that means is that inside of our parens we're going to have values separated by a comma, and you'll see how that works when we get down and start writing the code. But to get input, that's not something we've done before. To get input, we're going to work with a couple of functions called raw_input and just plain old input. And those both get their information from the keyboard. So that's how we are going to collect input into our program from the user who's standing at the terminal. They are in interactive mode. They have to type this information on the keyboard. They actually hit the enter key. Both of these commands make you hit the enter key when you're done. And that's going to get our information into our program, and it's going to store it in a variable. That's real important. Remember, we learned about variables. The information comes out of those functions and goes into a variable that we define in our program. Now the difference between these two functions is a little bit esoteric. A couple of things to note. Raw_input only exists in Python 2.x, and actually in 3.x it's the same. Input is the same as raw underscore input. Input in 2.x is a little bit different. So we need to use both commands since we're working in 2.x inside of this framework. But primarily we're going to work with raw underscore input. Just note that if you're working in Python 3, raw underscore input does not exist, and you're just going to use input without that raw underscore in front of it. We're also going to introduce a few new operators throughout this nugget. And operators, remember, are little things like the equal sign that we saw that we use as the assignment operator. We're going to use the equal sign in this nugget in order to assign the values from the input statements to our variables. Well, we've got a couple of new ones that we'd like to go over, and those are plus, minus, multiply, and divide, and they work exactly the way you think they would. Addition, subtraction, multiplication, and division. The big thing that we're going to pay attention to in this nugget is how they are different based on the data type that we're looking at. So your variable changes whether it has text or it has a number, and the functionality of each of these operators also changes based on whether you're using text or numbers. After all, what does it mean to multiply a text value? What does it mean to add a text value versus a number? So we'll take a look at that, but let's go ahead and get started and start writing some code. So let's start simply and gussy up our print function a little bit to do some different stuff than we've seen it do in the past. So to start with, here's my simple print function, and it's printing out the text hello world. I can see that work right over here. I just type python io1.py hello world. So that works just like we expect, but sometimes we want to do more complicated things with our output. We don't always want to have an individual value print out with our print statement. Sometimes we might want to print multiple values and have them stuck together, or concatenated is the word. Now print is a function in Python 3.0. It's a statement in 2.x, but we're going to use the 3.0 version of print. It's a little bit simpler to work with. And functions take parameters. What's actually going on here, if it's not clear, is that this print function, which is print open paren, is taking as a parameter, a single parameter, the value hello world. It's taking that individual string literal as a value, and that's being passed into the print function. The print function knows what to do with it. Well, we can actually pass multiple values, multiple parameters into many functions, including the print function. And let's take a look real quick at how that works. If I open up a new shell window here, and I'll go ahead and open up my interactive mode Python prompt. Notice the three open brackets there. And we're going to take a look at a function called CMP, which is the compare function. And that just tells us if two numbers are less than each other, equal to each other, or greater than each other. So let's say I'll start with 5, 10. What I'm doing here is I'm calling the CMP function, and I'm passing in two parameters, the number 5 and the number 10, and they're separated by that comma right there. So parameters get passed into functions, and they are comma separated. And some functions only take a single parameter. You can't pass more than one. Some take 2, some take 3 or 4, as many as you want. It depends on the function that you're calling. The CMP function in our case takes 2. I hit enter, you see it returns, it gives me back a -1, telling me that 5 is less than 10. So this function is not going to work if I only pass in a single parameter. If I just say CMP5, it has nothing to compare. It actually gives me an error if I try to pass in one, and it tells me very clearly that it expected 2 arguments and it only got a single one. So I do need to pass in 2 parameters, 2 values to my compare statement. But also notice that the order of those parameters is important. Compare 10, 5 returned a value of 1, whereas 5, 10 returned a -1. And that's because 5 is less than 10, but 10 is greater than 5. So the position of the parameters in that list of parameters, that comma-separated list, is really important, and it makes a difference. And it's going to make a difference on our print statement right now, where we use multiple different parameters inside of our print statement. Notice that I've got print hello, comma, world, exclamation point. And the position is important because it's going to print hello, then it's going to print world. If I swapped those around, if I had world in the first position and hello in the second position, it would say world hello, which wouldn't make any sense. We want it to say hello world. Also, just as a note, I've got this little import statement at the top of my script here. That's because I'm on 2.x, and this tells me to use the 3.x version of the print function, which is what we want to do. If you leave that statement out of the top of your file, the print function isn't quite going to work the way you expect it to. So if I go ahead and come back here and run this second version of my command, I'll say python io2.py. You can see hello world, both times it printed that out exactly the same way. And that's because the print command takes parameters, positional parameters, and adds them together, or concatenates them is the word, so that they're all stuck together in a big long string. It can actually make a small change to this. You could imagine if I did a third parameter like this. Now I've got hello and world and the exclamation point. I'll go ahead and save it. I'm going to run it again. And notice what happened. It worked pretty much exactly the same. It printed the first parameter, then the second parameter, then the third parameter. I could do that on and on. I could put 10 parameters in and it would just print them all out like that. But notice that it added a space in for me. It did it where I wanted it, between hello and world, but it also did it between world and exclamation point. Now we're going to talk about how to deal with that. I've got up on screen here the online documentation for Python. That's a good site to have handy when you want to look up some syntax. And I'm looking specifically at the print function. And I want to point out that it's got a few named parameters. The two we're concerned with are sep and end. And if you don't know how to use named keyword parameters in Python, well, I'm going to show you how right now. The basic point is, before, when I was talking about the position being so important, sometimes you need to use keywords to define your parameters, a named parameter. And that's done simply like this. You add as another parameter here. All I've done is done a comma and then another parameter. And this parameter has a value that has to be named according to that syntax from the documentation. So SEP, it has to absolutely be that. And then the assignment operator and the value that I want SCP to equal. So it's like I'm passing a variable in to my print function, but if I didn't include the name of the variable, my print function would simply think that it was another string that it was concatenating onto this list of strings, and that's not actually what I want it to do. By naming it very particularly, SCP, I'm telling print that this is the key that it should use to separate the strings that I passed earlier. So by default it was a space like we saw, but now that I've changed it to be a null length string, a zero length string, when I run my command, notice that it's all smushed together. So now instead of my different pieces of text being separated by a space, there's no spaces at all. They're separated by a zero length string, which is good for my exclamation, bad for my hello and world. So we'll take a look in a few minutes about how to deal with that. The other named keyword that we want to look at for the print function is the end keyword. And all that does is simply tell us what to use at the end of the string. So by default, it was a new line. Notice that hello world and hello world were on two separate lines, even though I never actually told it to print a line break. Well, that's because the default value for the end keyword parameter was a new line. When I explicitly define it, as I've done here, and I say, again, a zero-length string, now when I run my command, notice that no new line is printed, and these just run together on the same line. So you can pass in these keyword parameters. They'll override the defaults, and you can always look up the defaults right here again in the documentation. Notice that for separator, the default is a space, and for end, it's \n, which is, a new line. One last important point about these keyword parameters: they don't build up over time, so they only apply to the print statement that they were assigned to. So if I make another one here, this is an example, and I go ahead and save this, you'll notice that the end and the separator don't apply to my third statement. So after my second statement, I still got a new line, and my third statement uses a space again for the separator. It doesn't use the blank. So each of those keyword parameters that we passed into the print function only applied to the print function that they were passed into, and not to subsequent print functions. Now let's get some input from our users. Let's see how we can capture some keyboard text and print that back out on the screen. And you should be able to imagine, based on our earlier conversation already, how this is going to work. Here I've got my new little piece of code up, and I'm still importing the new future print function. And now I'm using the raw underscore input function. Again, that's a 2.x only function, so if you're on 3, just use input, plain old input, without the raw underscore in front of it. And again, based on what we've learned, you can see that I'm passing a parameter into the raw input function. Specifically, it's the parameter, please enter your name. And then I'm using the assignment operator, and I'm assigning the value of raw underscore input to the username variable. So what we're seeing here is we're seeing a function, raw underscore input, that actually has a return value, it's called. So information comes out of this function, and we want to capture it inside of our program. And where do we store information in our program? We store it in variables. Raw input, very specifically, is going to capture whatever is typed as a string and put it into the variable on the left side of the assignment operator. In this case, we called it username. And I've got a little syntax error here. I want username. So if I go ahead and run this, it's going to be python io4.py. You can see it says, please enter your name. So this is how the input function works. It takes the text that you pass into it and prints that out on the screen, and then it waits. And specifically, it waits for me to type something in and then press the enter key to finish. And after I do that, it moves on to the next statement. Hello, Benjamin. I've got it again here. So just to recap, what happened is it ran this statement right here, but raw input stops and waits for me to hit the enter key. So it didn't do anything. It didn't perform the next line in my code until I had hit the enter key, at which point it moved on, and I used the print command with my parameters, my positional parameters, to print hello space Benjamin and then space exclamation point. Now once again, I've got my spaces and my not spaces mixed up here. I want a space between hello and Benjamin. I don't want a space between Benjamin and the exclamation point. And how can I handle this? Well, we're going to introduce another one of those operators that I talked about. In this case, the addition operator. Now, since we're working with text, it's not actually called the addition operator. And this is going to be a real important point here. The operators change based on the context of what you're doing. So right now, using the plus sign with two different pieces of text, two strings as they're called, this is actually the concatenation operator, and it's going to do largely what you imagine it's going to do. It's going to smush those two strings together without regard to the print function separator value, because this isn't part of the print function. This is just an operator that's executing inside of this single parameter. We've only got one parameter here. It's username plus exclamation point. So I'll go ahead and save this and run it again. And now I get hello space Benjamin, and Benjamin has the exclamation point smushed right on it. And it might be a little bit easier to understand if you look at it or think about it like this. Let's say final name equals username plus exclamation point. And then down here for this parameter I can simply say final name. So what have I done? I've created a new variable. I've called it final name, and it's the username that we captured above plus the exclamation point that I want on it, and then my print command just passes in final name as the second parameter. Once again, this should operate exactly the same as my previous command, Benjamin, and it does. Hello Benjamin, with no space between Benjamin and the exclamation point. So the plus sign, the addition operator, or in this case the concatenation operator, allows us to add two strings together. Now let's mix up the data types that we're working a little bit with our input and output. So far in this nugget we've only used strings or text variables inside of our input and output. And the raw input function only returns text into the variable that we use with the assignment operator. Here we're using the input function, and the input function tries to be a little bit smart. It tries to look at what the user's keyed in and from that determine what the variable data type should be. So here where I'm asking to please enter your age, most people are going to type in a number, 20 or 25 or 30 or whatever, however old they are. And because of that, Python is going to turn age into an integer type variable. Now down here I'm showing off a few of the operators that we talked about. There's plus, multiply, and divide. They work exactly the way you would expect them to. Plus adds that number onto the age, multiply multiplies it, and divide divides it. And I've got some output statements down here so that we can see that in action. Let's take a look at how it runs just like this. My name is Benjamin and my age is 35. So notice that in 2 years I will be 37 years old. So I used the concatenation in the print function here to concatenate in my factor, my final age, and my username, and it got me this cool sentence: in 2 years I will be 37 years old, which is correct. It added the factor of 2 onto my age and came up with 37. I also have my age multiplied by 2 is 70. My age divided by 2 is 17, and that's a little bit wrong actually. 35 divided by 2 is not 17. But here's the problem that we ran into. Input took in 35 as my age, so it turned the age variable into an integer. Integers can't have decimal points, so when I ran the division function against it, it ultimately decided to round down. If I wanted it to be a decimal, there's a couple of different things I could do. One, when I run my application, I can actually type in 35.0. You and I both know that's equal to 35, but guess what? Python is going to look at that and decide that it's a float instead of an integer. And now when I run, you can see that my age divided by 2 is 17.5. So by including that 0.0, and also notice the age multiplied by 2 is 70.0, by including that 0.0, I told Python that this was a float to use right here, and that way it kept the decimals on the division statement. So it's real important to understand what your variables are coming in as. And obviously one of the big challenges here is that you may not know what your user is going to key in. I mean, after all, I could come here and it says Benjamin, and it might ask for my age, and I'm going to type my age is 11. Well, it's expecting a number. It's not expecting text 11, and you can see immediately what happens is I get a big fat problem. It says 11 is not defined. I can't key text in when it's expecting a number. And this is where something like good error handling comes into your application, your programming. That's outside the scope of this nugget, but we will talk about it later in the series. So keep that in mind, that you want to put a lot of error handling around any time you accept input from outside of your program, because you don't have control over what that input looks like. Now, I did mention that there was another way to deal with data type issues like we talked about, and real quickly I'll just show you how this works without getting too deeply into the explanation. Every data type in Python has a function associated with it that we can use to cast a variable to another type. So all this is going to do right here is say, for the purposes of this operation, the left-hand operand is actually the float of age, which is going to turn age, whatever I type in, into a floating point, and that means that the whole operation will return a float into my div age, and down here in my sentence, div age should return the floating point version of my age. And we can see that in action if I come here, io5.py, my name is Benjamin, and my age is 35, and there you go. You can see that for most of it, age remained without the decimal point, 37, 70, but for the purposes of that division, it actually figured out the decimals. So just another quick way that you can deal with scrubbing your inputs and making sure they are the correct data types. And that concludes this nugget on input and output with Python terminal mode programming. Just to recap, we took a look at the input and output functions that we were going to use for terminal mode programming, and that included both raw underscore input as well as input, and the output function print that we then took a look at how to parameterize. So we talked about the fact that we can pass multiple values into the print function, comma separating each of those values, and it knows how to concatenate those different values together to make one big long printed statement. We also took a look at named keyword parameters in the print function so that we could change the way that those strings were concatenated together and how the string ended, whether it had a new line or not on the end of the string. Then lastly, we took some input from the keyboard. We saw how the input function allows us to key something into the terminal window, wait for the enter key to be pressed, and then store that information in a variable that we could then manipulate. We could perform operations against it like plus and minus and divide, and print the results of those operations out on the screen, once again using the print function. I hope this has been informative for you, and I'd like to thank you for viewing.